Morning, everybody. Today we're gonna start new lesson 12.2, the arithmetic sequence. First, what's meant by arithmetic sequence? Let's take some examples or patterns of 1, 4, 9, 2. Here we are doing square for each number. 1 squared, 2 squared, 3 squared, and 4 squared. This is the pattern. And let's take another example. 3, 12, 48. As you see here, every time you are multiplying by the same number. Times 4, times 4. But if we take another example, 5, 10, 15, 20, 25. Every time here, we see that we are adding 5 to each term. And we can call this A1, means the first term, second term A2, third term A3, and fourth term A4, and so on. Here we have a common difference. D, we call it, which is equal to 5. Since 10 minus 5 is 5, 15 minus 10 is 5, 20 minus 15 is 5. So every time the common difference is the same, and it is 5. In general, we can say that an plus 1 minus the term before, which is an, is equal to d, which is the common difference. As an example, write first 5 terms of an arithmetic sequence with first term -2 and common difference is 8. You can have a rule: an is equal a1 plus n minus 1 times t as a rule here, and we can find any term if we have the first term here and we have a common difference. Going back to this example, if the first term was -2, I need to add every time 8 to get the next terms. So -2 plus 8 is 6. Then we add 8, 14. We add 8, 22. Then we add 8, it's 30. These are the first 5 terms. This rule will help me in finding any term I need if I have the first term and common difference. For example, if I told you find the 10th term of the arithmetic sequence, five, 10, 15, 20 and 25. Here, 10th term, it means A10 is equal to the first term plus 10 minus 1 times D. We are applying this rule. A10 is equal first term, which is 5, plus 9 times also the common difference is 5, as we said before. From here, it's going to be 50. So here, the 50th or the 10th term is 50. We have a general formula. General formula which is an is equal am plus n minus m times d. So here, as an example, given a3 is equal to 10, and we have arithmetic sequence with common difference is equal minus 1. Find A12. According to this formula, A12 is equal A3 plus 12 minus 3 to D. And the D is negative 1. A3 is given 10 plus 9 times negative 1 is equal to 1. So the 12th term here is 1. It's equal to 1. Another example, if you have, find the number of terms of the finite sequence 8, 4, 0, minus 4, 10, negative 24. For sure, finite arithmetic sequence. It is given to me that it's arithmetic sequence. First, I find the common difference. It's negative 4. Then I need to find the number of terms, which is n. So an is equal a1 plus n minus 1 times d. Negative 24 is equal 8 plus n minus 1 times d, which is negative 4. So negative 32 will be negative 4 times n minus 1. And n will be 9. So we have 9 terms in this finite sequence. Now we move to the partial sum of finite series. What's meant by series? The sum of a sequence is called a series. Okay, for example, if you have this, and you need to find its sum. This one is easy. We're going to use the formula of the partial sum finite series. It's as following. Sn is equal n over 2 times a1 plus an. N is the number of terms of the series. a1 is the first term and an is the last term. If you look here, how many terms do we have? 1, 2, 3, 4, 5, 6 over 2 times first term is 10 plus the last term is 60. And we're going to find the answer of this, which is 210. What about if the series was infinite? The sum of infinite series it's infinity. Why? Since it's infinite. Let's take another example. If you have to find the sum of the first 50 terms of the sequence 2, 4, 6, 8, and so on. So here I need to find the sum of the first 50 terms of this series. So here the sum, it means sum of the sequence is the series. So S50 is equal 50 over 2. Why? Since 50 is the number of the terms. The first term, which is 2, plus the last term, I don't have it. So I need to find the 50th term first. A50 is equal to A1 plus 50 minus 1 times common difference, which is from here, D is equal 4 minus 2, which is 2. So times 2. A1, it's 2 also, plus 49 times 2, it's 100. So here, the 50th term is 100. We substitute it there, and we find the sum of the first 50 terms of this sequence, or 50 terms of this series. We need to introduce this form. This we call it summation. This we call it the summation. When I say summation from I equal 1 to 5 for I, it means I replace I by 1, then by 2, then by 3, then by 4, then by 5. So this series we have I and 1 till 6. How many terms do we have here? The number of terms is 6 minus 1 plus 1. So we have 6 terms here. In general, if you have I from n till m, the number of terms in this series is m minus n plus 1. Number of terms is n minus m plus 1. As an example, I told you find the sum from I equal 1 till 60, or this 3i plus 5. First, how to find this? I replace I by 1, then by 2. Don't forget we have plus between them. There is summation. Then by 3. And we continue till we reach the 60th term. Actually, this will be 8 plus 11. But still, we have 185. The sum of this will be as 60, since we have 60 terms, as 60 over 2 times. First term, it's 8 plus last term is 185. And we find the answer. This will be the sum of series. Now we're going to take application of arithmetic sequence and series. Example. It's a real world problem. It's a problem from real life. Suppose that a job offers a starting salary of $75,000 with a raise of $4,000 every year. Question part A. Write an expression for the nth term of an arithmetic sequence that represents the salary as a function of the number of years of employment. And here we have an arithmetic sequence. An is equal A1 plus n minus 1 times D. First salary is 75,000, so plus n minus 1 times D, which is 4,000. The general nth term will be here 4,000 n plus 71,000. This will be the nth term of arithmetic sequence, which represents the salary as a function of the number of years. Part B. Gotta write it there. Find the total income for an employee who at the job for 20 years. So here I need to find first the salary after 20 years. So A20 is equal A1 plus 20 minus 1 times D, which is 4,000. A1, we said before, it's 75,000 plus 19 times 4,000. And it's going to be $151,000. This is the salary after 20 years. Now I need to find the sum of these salaries among 20 years, since he said the total income. So, using the formula of the sum, S20 is equal 20 over 2, 25,000 plus 151,000, which is equal to $2,260,000. Hope that you enjoyed this, and thank you for watching